I don't think that's the best way, and that's because there's not a lot of what's called thermal linkage. Now, if I were to bring my tip here and I were to put solder right in that joint, right in this V made between the leg and my iron, I can get thermal linkage between the tip of the iron and the leg of my component. Okay, so real quick, thermal linkage. Understanding this concept is going to help you a lot if you're going to do soldering. So with thermal linkage, it has to do with the amount of surface area contact that the soldering iron is going to make with the work. The work in our case is going to be the leg of the component and the pad of the PCB board. But it could also be braided wire or solid core wire or whatever you are trying to solder. So if you bring your solder in from this side, the thermal linkage is only going to happen at the contact area between the leg and the soldering, which is really, really small. That's like a super small surface area. So conduction can only happen through that point. So conduction happens very slowly, and you might not be able to get enough thermal transfer to heat this up to what you need. It's going to have a hard time melting the solder. Now, if you bring your solder in from this side, what's going to happen is you're going to melt the solder in here, and you're going to allow heat to transfer in a larger area. All right, that larger area of conduction is going to allow more heat to flow from your soldering iron into the leg of your component or your work. And that's going to get you a higher heat transfer rate, which is going to help you melt the solder faster, and you're going to have less problems. In this clip, you can actually see thermal linkage at play. As the solder is brought on the other side of the pin, there's some difficulty getting the solder to melt until the solder starts to flow, forming a conductive bridge for heat to transfer over.